This is how to charge and discharge a capacitor, as well as the basics of a resistor and how a capacitor works. A capacitor is like a battery, except it charges and discharges very quickly. Here we can see the two legs, the longer leg being positive and the shorter leg being negative. Now, on how to charge a capacitor, we're going to need the capacitor over here and the battery. Now, we're going to want the positive lead of the battery on this 9 volt, it's this one on this side, and the positive lead of the capacitor, which is, again, the longer leg, to be touching, directly or indirectly. So you could use an alligator clip or maybe some copper tape to connect them, with the negative going to the negative, positive going to positive. But in this situation, I'm just going to touch them directly. So it's negative and positive, and just touch it for a few seconds, and it's charged. Again, it charges very quickly. Now, on to use this circuit, which is going to be our discharge circuit, we're going to be using an LED and a resistor. Now, why do we need the resistor? Well, that's because if we just touch the LED to a 9 volt power source, it's going to explode, as it can handle between 1.8 and 3.3 volts, depending on the color. So, if we were to show with this resistor, we can now connect it with, I promise, this is the longer leg on this side, connect it to the resistor, making it the positive, and this is the shorter leg on this side, making it negative. So we connect the positive leg to the positive side and negative to negative. So you see it lights up without blowing up, which is important. So now remember, this is a charged capacitor. So again, we're going to take the positive leg to the positive leg and the negative leg to the negative leg. So as you see, if we can touch it, it comes on for just a second. The reason it flashed was because I didn't touch it for a consistent amount of time. But it's already discharged. It doesn't light up anymore. Here's the circuit for that. So this would actually be like this and like this if you were to look at it via the drawing. Positive leg on this side, positive side on this side. Something like that. So now we're going to discuss how a capacitor works. So a capacitor is basically 2 plates with wires coming off of them. So here are your 2 plates, and here are the wires, and they have an insulator in between that doesn't let the electricity cross, called a dielectric. Now these plates, whenever in their standard state, but without being charged, are going to have a few electrons in either of them, but not enough to actually have any effect on it. Now, whenever you connect it to a power source, electrons are going to start flowing to one of the plates, the negative one, the shorter end, and they're going to start building up on the plate. Now, whenever they start building up on the plate, they're going to cause a negative charge, and negatives don't like negatives, so all the electrons on this side are going to start coming off. Now, this plate has a lot of electrons on it and is now mostly negatively charged. This plate, which has very few electrons on it, has a basic positive charge. So now all these electrons want to get to this positive plate, but they can't because there's a dielectric in between, the insulator. But whenever you complete a circuit, for example, with the LED and the resistor, now these electrons have a path and they can rush over to the positive side. And everything they pass through, they power along the way. Now, what kind of resistor for this do we use so that the LED doesn't break? Because if you use too small of a resistor, it doesn't matter. The LED is going to bust anyways. Well, this is the basic calculation for it. So you're going to use the Ohm's law formula, which is here. Voltage is equal to current times resistance. So the voltage is going to be the voltage that we want to resist. So in this case, we only want between 1.8 and 3.3 volts. We're going to say 1.8 just to be safe. And then the max voltage that we can have is 9 volts, which comes from the battery. We're going to take the voltage of the battery minus the voltage that we do want to use, and that'll get us the voltage that we want to resist. And then we have our current, which we just need to know for the LED, which is about 30 milliohms or 30 milliamps, about 0.03 amps. And our resistance is what we're trying to find. So 9 minus 1.8 over 0.03 gets you 240 ohms. Now this resistor is 220, but as there is innate resistance in things like the alligator clip, it works out just fine.